In our first video, we learned how to convert between the moles of a substance and the particles of that substance using Avogadro's number 6.02 times 10 to the 23rd. We learned that 1 mole is equal to 6.02 times 10 to the 23rd, whatever. And then in our second video, we learned that you can also use moles to convert between the grams of a substance. Well, today what we're going to do is we're going to combine those two ideas together, as you can see right here, that when you look at moles, moles can go to grams, and moles can also go to the whatevers. And typically in chemistry, we call the whatevers particles. But again, it can be 6.02 times 10 to the 23rd, whatever. So remember that when we convert between the grams and the moles, what we use is we use the molar mass. That's what we did in our previous video. So anytime you're going between the grams of the substance and the moles of the substance, you will use the molar mass of the substance. And then to go from the moles to the particles, again, the whatevers, remember, we always use 6.02 times 10 to the 23rd. So remember that the molar mass is always some mass in grams divided by 1 mole. And again, remember, sometimes you're going to put moles on the bottom and grams on the top, and sometimes you're going to flip it depending on which way you're going. And that's why I just wrote molar mass here, because sometimes you divide by the molar mass. When you're going this way, you divide by the molar mass. When you go this way, you multiply by the molar mass. Okay, and again, we've seen why in terms of canceling and things like that. Okay, and then again, going this way, we learned that there are 6.02 times 10 to the 23rd, whatever, in 1 mole. And see how both conversions have a mole in them. And so when you convert, you're going to either put moles on the top or moles on the bottom, depending on how you need them to cancel. Okay, so let's look at an example that's done for us already. So if we have 5.23 grams of glucose, and they want to know how many molecules there are of glucose. So notice my first step here. Anytime you have the grams of a substance, hey, I'm not sure what to do. Anytime you have the grams of a substance, the first thing you're always going to do is you're going to convert to moles. Okay, and how do I do that? I use the molar mass. So I go to the periodic table, I look up the mass of carbon, I times it by 6, what we've done in our previous videos, the mass of hydrogen times 12, the mass of oxygen times 6. I add them all together and I get 180 grams per mole. And again, notice I put grams on the bottom so that those grams will cancel. So now I've got moles. If I were to stop, forget all this stuff here, if I were to stop right now, my answer would be in moles of glucose. Okay, I don't want moles, I want molecules. So notice I don't even get an answer here. I just keep going. I make another multiplication sign. I make another line here. And since moles are on the top, moles again have to go on the bottom. So what are they going to do? They're going to cancel. So moles and moles cancel. And in 1 mole, there are 6.02 times 10 to the 23rd molecules. So now I'm done. I've canceled grams, I've canceled moles, and now I've got molecules. So in my calculator, I'm going to type in 5.23 divided by 180.0 times 6.02, hit the exponent button on my calculator, hit 23, and then hit equals. And you should come up with that answer right there. And again, notice I've got 3 digits here. I started with 3 digits. Okay. Now, let's do the same thing. Now we're going to actually do it, though. So I did that first one for you. Let's do this one here together. Let's take 64.2 grams of H2 gas. Okay, and again, what's our first step? Anytime you have grams, what is the only real step you can take is you can convert to moles. So hydrogen has a mass of 1, but there's 2 hydrogens. So that's 2 grams in 1 mole of H2. And then my next step, and again, what happens to my grams? They cancel. And that's why it's so important, guys, that you write your units in there so you can see things canceling. And so you're never having to guess what's my next step? Because now I know in my next step, I have to have moles on the bottom because I have moles on the top. Okay, so I know in my next step that 1 mole is going to equal, what does a dozen equal? A dozen equals 12. What does a mole equal? A mole equals 6.02 times 10 to the 23rd. And what are they asking me about here? Remember, because it can be whatever, it's molecules. Again, no abbreviation for molecules. Okay, and now that's it. So now I get my calculator. I type in 64.2 divided by 2 multiplied by 6.02 exponent 23, and I get 1.93 times 10 to the 25th, and those are H2 molecules. Okay? Now, the only other thing that's tricky here, well, first of all, we're going to do a couple more examples. If we go back to example 1, the only other thing that we're missing here in example 1, let me kind of erase all my work that I've already done here, is we know that in this molecule right here, there are 6 carbon atoms, right? Right here, we can see that. There's 12 hydrogen atoms, and there are 6 oxygen atoms. So we can say that 1 molecule equals, and we could say 6 carbon atoms, or we could say that 1 molecule equals 12 hydrogen atoms, or 6 oxygen atoms. So there's one more step that we could do here, where if in that first question, so coming back to this glucose question, if we started with the same number, but they asked us, for example, to find the number of atoms. So, for example, here, what if the question were to ask us, how many hydrogen atoms are there? Notice that the very first part is the same. We convert grams to moles, just like we've always done. We convert moles to molecules, like we've done. But now notice my last step. Notice that grams cancel, moles cancel, and I have molecules left. My last step that I can do is I can say that 1 molecule, so that molecules cancel, 1 molecule of this actual molecule of C6H12O6 has 12 hydrogen atoms in it. Okay, and how do I know that? Because I look at the chemical formula. So notice this extra step that I just added right here is if they ask you about the atoms in a chemical formula, what do you use? You use the chemical formula to convert from this is the molecule, and now we're looking at the individual atoms in that molecule. Let me show you a couple of examples of this. If you can get examples 3 and 4, all of the questions you're going to have regarding this are going to be easy. So, calculate the number of phosphorus atoms in 6.55 grams of Ca3PO42, calcium phosphate. So I've got 6.55 grams of Ca3PO42. What's the thing I do with grams every single time? I convert to moles. So I'm going to need a calculator for this. So calcium is 40.1, and there's 3 of them. So I'm going to multiply by 3. Plus phosphorus is 31. There's 2 of them, so that's 31 times 2. Plus oxygen is 16, and again, notice that 2 outside, there's 8 oxygens. Okay, and that equals, and again, check your work as well, 310.3 grams in 1 mole of Ca3PO42. Okay, and now, once I have grams, what's my next step always? Again, if you're not sure, come back here and look at this. This is kind of the map you're going to follow. So right now I'm at moles. What's my next step? I've got to go to particles. Okay? And how do I do that? I use 6.02 times 10 to the 23rd. So in 1 mole of Ca3PO42, there are 6.02 times 10 to the 23rd particles of Ca3PO42. And now they're asking the number of phosphorus atoms. Okay, so here's my last step in one particle of Ca3PO42. How many phosphorus atoms are there? And again, what do? You look at the chemical formula. And you go, it's Ca3PO4 parentheses 2. So that means that this 2 distributes through to the oxygens and to the phosphorus. There are 2 phosphorus atoms. Okay, and now we're done. And notice that grams are going to cancel, moles are going to cancel, particles cancel. Everything has to cancel except for what they're asking you for. So then I take my 6.55. So in my calculator, I'm going to go 6.55 divided by 310.3. So divide by 310.3 times 6.02. Hit the exponent button, whichever button that is for you. 23. And guys, if you're ever having calculator issues, just ask, just talk to me and say, hey, I feel like I'm typing it into my calculator correctly, but I'm not. Can you help me with it? Of course I can help you with that. Okay, and then I multiply by 2, and I get 2.54 times 10 to the 22nd phosphorus atoms. So that's the whole thing. That's starting at grams and going all the way over to here to atoms. Of course, what we can also do is we can go from atoms all the way back to grams. And that's what example number 4 is. I would strongly recommend that you stop at this point. We're starting at atoms. We have to get to grams. Okay, stop the video right now and see if you can do this one yourself. And then come back and check and see if your answer matches mine. So I'm going to start with 4 point, the only number they give me, right? Times 10 to the 23rd O atoms. So again, in this case, I'm starting here at the very end. I'm starting down here at atoms, and they're asking me for the mass, so I've got to get all the way back here to grams. So what's the first thing I'm going to use? I'm going to use the chemical formula, of course, to get the particles. So the chemical formula, it's talking about oxygen atoms. How many oxygen atoms are in this chemical formula? And again, atoms are on the top, so atoms have to go on the bottom. Okay, in one particle of barium chlorate, BaClO32, there are 6 oxygen atoms. So I'm going to start by writing 6 O atoms. And notice that big space that I leave between the 6 and the O. The reason that I do that is because when I go to my calculator, sometimes that looks like a 60. Okay, because of the O, it looks like a 6 and a 0. And sometimes I'll type in 60 in my calculator. So I really try to leave a lot of space between the 6 and the O for oxygen. So there are 6 oxygen atoms in one particle of BaClO32. Okay, and now let's keep going here. And again, guys, don't ever guess. Don't ever guess what goes on the top and the bottom. If it's particles up here, particles have to go down here. So remember, our conversion from particles back to moles is using 6.02 times 10 to the 23rd. And remember, you're never going to have 6.02 times 10 to the 23rd moles. It's always 1 mole. So if you're like, well, I don't know if the 6.02 times 10 to the 23rd goes on the top or the bottom. Remember, the moles are always 1. So if this is particles, then the 6.02 has to go on the bottom. And that is equal to, what's 6.02 times 10 to the 23rd equal to? What's 12 equal to? 1 dozen. What's 6.02 times 10 to the 23rd equal to? 1 mole. Okay, and then my last step, I've got moles, so particles cancel. I've got moles on the top, so now I have to put moles on the bottom. And remember, the number in front of mole is always 1. So in 1 mole, there are, and again, remember guys, I'm just following this map right here. I'm using this atoms to particles, and then I did particles to moles using 6.02 times 10 to the 23rd. And then to go from moles to grams, I have to use the molar mass. So my last step is I have to get the molar mass of barium, which is 137.3. And then there's 2 chlorines, so that's 35.5 times 2. And then there are 6 oxygens, so plus 16 times 6, which is 304.3 grams in 1 mole. And so my moles cancel. And again, notice what mass. They're asking about the mass. And hey, what do you know? I've got grams. So I'm going to take 4.94 times 10 to the 23rd. So 4.94, again, hit exponent or double E or times 10 to the, and then hit 23. And then I'm going to divide by 6. Do it, type it in just like this if you're not getting the same answer as me. And then notice we have 2 divisions in a row. Divide by 6, and then we're going to divide again. That's how you type it in your calculator. 6.02 exponent 23. So divided by 6.02 times 10 to the 23rd. And then that 304 is on the top, so times 304.3. So times 304.3 equals, after all those 23rds canceling out, I end up with 41.6 grams of barium chlorate. And that is my final answer. And again, the key to this whole thing is right here. I'm trying to give you as hard of problems as I can. Okay, but what if they give you moles, for example, and they just ask for particles? Well, then you're just doing one step, right? You're just going from here to here. What if they give you molecules and they ask you for grams? Well, then you're just going from here to here by going to moles first and then from moles to grams. Okay, no matter where they start, there's 4 different areas you can start: grams, moles, particles, or atoms. And I've given you, we just did 2 examples, one where you went from grams all the way to atoms, and another one where you went from atoms all the way back to grams. Because again, I want you to see that whole thing. But most of the time, you're not going to have to do that whole thing. It might just be something as simple as converting grams to moles. Maybe just that part right there. Okay, and if they do, just think, okay, where am I starting on this little map he's given me right here? Where am I starting, and where do I need to get? And if you use that, oh, I'm starting at particles, great. And where do they want me to go? Grams, great. Okay, so this is what I'm going to do, here to here, and then here to here. Okay, but always try to figure out where's my starting location and where's my final location. Where am I starting at, and where do I need to get? Okay, it might be moles all the way over to atoms. Okay, and how do you do that? You go to particles, and then you go to atoms. So figure out where you're starting, figure out where you're ending, and then figure out how do I get there. Okay, and that will keep you on track to converting between grams and moles and particles and atoms.